Under the brain-first hypothesis, the most neuron-related event is cephalization, the origin of the anterior brain around 450 million years ago, because the brain acts as the primary architect of every neuron's identity, connectivity, and survival, while the Cambrian explosion's neural refinements, 540 to 500 Ma, were merely cellular tools awaiting a centralized director. Before cephalization, even with the Cambrian's newly specialized neurons, fast synapses, and early axonal ensheathment, these components operated in loose nerve nets or simple ganglia, like having high-performance wiring without a control panel. The Cambrian explosion gave neurons speed and precision, but not purpose or integration. Cephalization changed that. The emerging brain secreted molecular gradients, e.g., Schur, FGFs. That forced neurons in different locations to adopt distinct neurotransmitter fates, cholinergic in one nucleus, glutamatergic in another, while also guiding axon growth via chemoattractants released from brain regions. This meant that the Cambrian refined synaptic proteins and ion channels were now deployed not randomly but within structured circuits. Furthermore, the brain's spontaneous electrical activity regulated neuronal gene expression and supervised synaptic pruning, turning generic Cambrian-era neurons into functionally dedicated units. Without cephalization, the synaptic speed and myelin-like insulation that evolved during the Cambrian explosion would have remained scattered, impressive but unorganized cellular parts. With a brain, those parts became integrated into a hierarchical command system. Thus, while the Cambrian explosion built better neurons, cephalization made those neurons neuron-like in the full sense, polarized, plastically wired, and survival-dependent on central signals. That is why, starting 450 million years ago, the emergence of the brain is the most neuron-related event of all.